We're talking about the formula for compound interest. A equals P parentheses, and this exponential. The A is the total amount, principal plus interest. The P is the principal. The R is the rate, the annual rate of interest. The N is the number of pay periods. So you will have either monthly, quarterly, semi-annually, whatever. They'll tell you what it is. The N here and here are the same, and the T is the number of years. Right. Don't turn it off, Kenny.
P is principal.
P is the principal.
What is A? Total amount.
Total amount.
Is that N times T up there?
It is in the power. It is N times T. In other words, you guys want a copy of this in your email? So I could give you a copy of that too.
Is annual rate R?
Yes, it is.
What's N?
N is the pay periods. So like if we're paying monthly, it's going to be 12, quarterly 4, daily 364, so forth.
And then T was the number of years.
Yes, T is the number of years. All right, so are we ready? You'll need your calculators off because we want to do an example with compound interest. How much money do we want to invest?
$60.
Let's do $200. And just say for right now we get 2% interest, and how long are you willing to set this money aside?
3 years.
3 years.
No, 2 years.
All right, so on your paper you would write down the formula. And now we would substitute in what we know. Well, we know the principal is 200. We know we have 1 plus, now that rate, oh, let's compound monthly too. The rate we have to change to a decimal. And then we have 12 times 3. So in your calculator, I want you to type this. 200 times, parentheses, 1 plus 0.02 divided by 12, caret 36. Because I did the 12 times 3 in my head. So put this into your calculator. Again, you need to have this down so you know what you need to type into your calculator. And it's money.
Wait, how did you get the 12?
I told you it was monthly.
Okay.
So
Oh.
that's where the 12 came from. Justin, you got an answer?
212 point, do you want us to round it?
It's money, 212 and...
0.36, because it's 0.356.
Agrees or disagrees? So it tells me that at the end of 3 years, I have earned $12.36 on my original investment of $200. Okay? Now, one other example problem that we're going to do, and then we're going to look at homework. This is on half-life. Yes. You're going to go? And I will send this.
Send that to me.
Okay. So now we want to talk about half-life. Okay, Bell. say that I have some type of chemical that has a half-life of 21 days. So at the end of 21 days, half of it is gone. Okay? And say that I start with 100 milligrams of whatever chemical I have here. Works for me. So if it has a half-life, what will the base be? It has a half-life. So what will the base be? Half. So we have our equation, and this is the type we always have. We have our original 100 milligrams. We have a half-life. Now, here's the problem. They don't tell us right off the bat how many days we want to check. But I know that every 21 I'm losing half of it. So the easiest way to deal with that is this power, you want to make x over 21. So if I put 42 up there, I know that's 2 half-lives, and I can deal with it. But if I had 43 days or 45 days, we can still calculate how much half-life by letting our calculator do the work. So this is what I want you to type in. I want you to type in 100, hit the times, parentheses, 1 divided by 2, caret. Now, how many days are we going to check? 45 days?
Yeah.
So let's check how much we have in 45 days. So you would put another parentheses and put 45 divided by 21. And then hit your enter. That will tell you how much of my original 100 is left after 45 days. So again, you put 100 times, parentheses, 1 divided by 2, close parentheses, caret, parentheses, and then the fraction to find how many half-lives. So, round to the nearest whole. How much do we have? Pardon? 23? And that makes sense because 45 is over 2 half-lives. So the first one would be down to 50, and the second one would be down to 25, so it would be less than 25. All right. Now remember, when we take that quiz on Wednesday, you have to know your 5 rules of exponent and how to simplify with those. Then we had scientific notation for a day, and then we've had 2 days, we had a day on sequences and 2 days on exponential equations. We're going to deal with growth and decay, and then we're just doing applications, either with compound interest or half-life. Do you have a question?
Okay, I don't get the b equals 1 plus r.
All right. The 1 is always there because we have 100% of something. If it's increased, it'll be over 100. So it will be 1 plus r. But if it's a decay, it's less than 100, so that r is going to be negative. And that's basically how we got, like right here. This was less than 1. That is just a formula that you always have to have with you. And if you have questions, we'll talk about study. Any other questions? Yes, ma'am.
On the sequencing day, I was on study hall, but
That'll work. I'm good to you. Any other questions? Kenny, you can close this one down.